Okay, students, we're going to follow these steps to balance chemical equations. If you don't already have your spiral out, make sure you have your spiral out and you have it labeled on the top, balancing chemical equations, because you are going to take just a few notes on this. So let's take a look at these steps to balance them. Okay, so the whole reason we're even trying to make sure that these equations are balanced is because of the law of conservation of mass, matter, or energy. And what that law says is that nothing can be created or destroyed. The matter or mass or energy, it's just changed into other things, but it never goes away. You can't just create something or just get rid of it. It never goes away. It's just transferred into different things. So this is the reason why balancing equations is so important. So you do want to write down each one of these numbered steps, and you also should have an example written in your notes. So this would be a good example to have in there, and you do want to write down these numbered steps. Okay, so the first thing that we're going to be doing is we're going to you want to go ahead and write this equation, okay? And notice that we have these lines left in front of our compounds or elements, and you want to have those there because you may end up putting a number in there. Just like in math, when you have a variable, it is assumed that there is a 1 in front of it, because if I had a 0 here, why would I even be writing the element, you know? So once you have this equation written down, let's go ahead and move forward. Okay, so we have Cl2 plus NaBr, and it goes to, in a chemical reaction, NaCl plus Br2. After you have this written down, you're going to be drawing a vertical line on one side of the arrow to separate the products and the reactants. So go ahead and draw that line. Doesn't matter on which side of the arrow that you have it, but boom, there's my line. You're then going to label the reactants and the products. So the reactants are the substances that are present at the beginning of the chemical reaction. And the reactants, they're consumed in order to make the products. So we have these are the reactants. Now on our other side, we have the products. The product is what is formed after a chemical reaction is finished. And this arrow is what tells you that a chemical reaction has happened. Now remember, with the arrow, it always points to the finished product, and the arrow can also be called the yield sign. And we want to recognize the fact that the number of atoms on the product side are going to equal the number of atoms that we started with on the reactant side. We're then going to list the chemical symbol of each element on the reactant side. We're going to count and list how many atoms are present. So I'm going to go ahead and look at, I have Cl here. Now I want to start to look at what is this right here. So we have 2 of these, and these are called subscripts. And what they do is they follow around whatever element is to the left of them. They don't apply to anything else except for the one they are directly next to. It's kind of like those sharks that have all those fish swim with them and eat like dead skin off their body. That subscript. The little fishies are the subscript. They follow their element. Or like the bird that hangs out with the livestock and they eat all the fleas and like the ticks and everything. Yep, those are your subscripts. You want to stay with your elements. Okay, so going back to listing our chemical symbols of each element on our reactant side, we're counting and listing how many atoms are present. So I'm going to write down my first reactant, and I have Cl. Okay, so Cl, when my subscript goes with my element to the left of it, so I'm going to go ahead and I say that I have 2 Cls. The next element I have over here, we have Na, or sodium, and how many do I have here of these? I just have 1, right? So 1 of them. Okay, then I go to Br, and again, I only have 1 of Br, so now I have listed all my chemical symbols of my elements, and I've listed how many atoms are present on my reactant side. Yoo-hoo! Oh, but wait, don't worry. Now we're going to do the same with the product side. Okay, now what you want to do is you want to go ahead and list your elements all in the same row, the same element in the same row. That way you can directly compare and contrast whether you have the same number. So I'm going to go ahead and I look at my CL on my product side, and I have how many of these? Yep, just one. Then I'm going to go ahead and write about my sodium, my Na. I have one of these. And then I'm going to look at my Br over here, and my subscript tells me that I have 2 Br. Now, when I'm looking at this, guys, we notice already, right? How many CLs do we have over here compared to how many do we have over here? Do they match? No, right? So we're going to have to fix that. So after counting, if the atoms on both sides of the equation do not match, then choose one element that doesn't match, just like chlorine here doesn't match, and figure out how to make the number of atoms the same on both sides. And how we're going to get the atoms the same on the both sides is we are going to multiply. How we're going to multiply is we're going to be adding coefficients. So coefficients work like the distributive property in math, multiplying, and they affect everything up until a plus sign, or an arrow or yield sign. Okay? Now, our coefficients, in order to make the number of atoms equal, you must add a coefficient. And a coefficient is going to be a whole number in front of a compound, which represents the number of molecules in the chemical formula. That's why we have these lines here in case we need to add coefficients. So I have 2 CLs on my reactant side. What I'm going to look at is how am I able to get 2 CLs on my product side? What can I multiply by 1 to equal 2? So I can multiply 1 by 2. So I'm going to cross this out, add my 2, and I need to add a coefficient 2 here, so then it distributes to my CL, and I have 2 CLs on my product side. I have 2 CLs on my reactant side. But what did you notice, guys? If I add that 2, what else does it change? Oh, it goes to both, right? So if it goes to C, because it's distributive property, it's also going to go to Na. Okay, so now how many NAs do I have? I have 2, right? So I'm going to have to cross this out, and now I have 2. Okay, now notice, I started with trying to balance just 1. But sometimes when you add that coefficient, it's going to mess around with your other numbers. So you have to see how your coefficient affects any other element within your equation. Also remember, students, you can never change the subscript. You can only change the coefficient. You can never change the subscript. You can only change the coefficient. Are they balanced yet? 2, 2, 2. All right. Now what do we do? Okay, so we're going to repeat steps 3 through 5 until all the atoms are equal and balanced. So sweet. I have Cl2, Cl2. Great. But now I have Na, I have 2 on my products and 1 on my reactants. So you want to ask yourself, what can I multiply by 1 to equal 2? And just like we did on this side, you're going to multiply it by 2. I'm going to put my coefficient in front of Na. Distributive property is going to be 2 times it, and I'm going to end up with 2Na. Now again, notice, students, if I add a 2 here and it goes to my Na, what else does it go to? My Br, right? So I have 2 Na. I also have 2 Br. Now, check it out. I've got Cl2, Cl2, Na2, Na2, Br2, Br2. Winner, winner. It's balanced. Yay. Okay, So now what I want you guys to do is remembering this law of conservation of mass, matter, or energy. We have to have our equations balanced because matter or mass or energy is never created or destroyed. It's either recombined or rearranged, but it can never just disappear or pop up out of nowhere. What I'd like you to please try to do is write these two equations down in your spiral and try to balance them with the steps that we went over. Once you have them balanced, please go ahead, try both of these games. They are a different way to practice your balancing chemical equations. Some of them deal with making sandwiches, which is never a bad thing. And then you can see if you can actually, it helps too to visualize some of this, and you can have practice with a couple different models. Okay, so make sure you are asking questions if you need to about any of this content, and also you want to make sure that you go through this PowerPoint, pause and re-watch as needed. Okay? All right, see you later.